Alrighty, today we're going to do multi-digit division, but we're going to focus on a single-digit divisor. So the number that we're dividing by is going to be a single-digit number, just as a nice review, hopefully. So we'll go in and start with some practice, and I'll show you the way that I like to teach it and the way that I learned best doing it. And of course, if there's another way you like learning it, or you like doing it, go for it. Whatever works for you, and as long as you're on the right track, getting to the right solution. All right, so let's start with our first problem. We'll label it A, and we're gonna do 5 divided into 3,764. Okay. Now, when I'm starting students with long division, I always start, just about with everything I do, I start with listing multiples, because I find, especially in long division, that really ends up helping us make fewer mistakes as we go through. So I like making little multiple tables over here. So we're trying to get 5 to go into this whole number here, right? So that's what we're going to be counting by, is by 5. Now, a lot of kids seem to like counting dots. So most of us can probably count by 5s, but if not, you can just count the dots. So over here, I'm going to just list 1 through 5 for now. And then over here, because this will be how many times it goes in, over here I'll count by 5s, and these will be my multiples of 5. So 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15. And you can see I haven't even looked at the problem. I'm just looking to know what I'm going to need to count by and know my multiples of to be able to do the long division. And I like to do the first 5 and then see if I need to go further. So 5 times 4 is 20. 5 times 5 is 25. Now, if I didn't know my 5s, that's where the dots come in as I can count. So if I'm at 5, 6, 7, 8, 9, 10. 10, 11, 12, 13, 14, 15. 15, 16, 17, 18, 19, 20. The dots are just kind of there to help you count and figure out what the next multiple would be. So now I'm going to go to my, again, I like to just list the first 5 because sometimes you don't really need to list all of them. Sometimes you do. But I like to list the first 5 just to start. All right, now I'm going to go to my long division here. So I'm trying to figure out how many times can 5 go into 3. And what I always ask kids is, how many times can a group of 5 go in and sit at 3 chairs? So if you're going into a restaurant with a group of 5 people and there's 3 chairs, how many times are you going to be able to do that? And in this case, you can't do that. 5 people cannot sit in 3 chairs. It's going to be really awkward. So when we say that it can't happen, we put a 0, and you can remember that like it's a no. Can 5 go into 3? No. And the 0 is our O for our no. All right, so now 5 times 0 is 0. And now we're going to subtract to see what we have left. Well, 3 minus 0 is 3. And we're going to go to that next line and bring down just the next number. So the next number here is the 7. Excuse me. So now I'm trying to figure out how many times can a group of 5 sit in 37 chairs. So how many times can 5 go into 37? Well, I'm looking over here, and I stopped at 25. That's not close enough to 35. I want to get as close to 35, or 37, excuse me, giving it away there. I want to get as close to 37 as I can without going over. So I'm going to go to 6, so 25, 26, 27, 28, 29, 30. Well, I might need to go a little further. So 7, 30, 31, 32, 33, 34, 35. Now that's looking pretty good, but just to be safe, 35, 36, 37, 38, 39, 40. So see, right there I went too far. It's past 37. So I know I'm going to go with 5 times 7 is 35. So how many times can 5 go into 37? It's going to be 7 times, so the 7 goes up here. It can happen 7 times, and 7 times 5, we don't need to do it in our heads now. This is where our multiples listing our multiples comes in handy. 7 times 5 is 35. I have it right here. I don't have to think about that anymore. So 35, and I'm going to subtract, and 7 minus 5 is 2. 3 minus 3 is 0. So we have 2 left over from that step. Again, I'm going to go to the next line, or the next number, and bring it down. I like to draw the arrows because it helps me remember where I've left off. So the 6 is going to come down and join that 2, so now I have 26. How many times can 5 go into 26? So on my multiples, I'm going to see as close as I can get to 26 without going over. So I have 25 and 30. 30 is not going to work because it's past 26, so I'm going to go with my 5 times 5 is 25. So again, how many times can 5 go into 26? 5 times. 5 goes on top. And 5 times 5 is 25. We subtract. And 26, or 6 minus 5 is 1. 2 minus 2 is 0. So we have 1 left over. Bring down my last number of 4. So now I'm going to see how many times can 5 go into 14. Well, 5 goes into 14. If I look at my multiples, 15 is too big. So I'm going to go with 5 goes into 14 2 times. And 2 times 5 is 10. I subtract and I have 4 left over. Now, for the purposes of just learning long division, we're just going to go ahead and say that the remainder is 4. As we go forward and learn more about long division and we go into decimals, we will do something after this step, and we won't just call it a remainder. We'll keep going with that division. But for this purpose, we're just going to stop and say that 3,764 divided by 5 is 752, remainder 4. Okay. Let's go ahead and try another example. Let's do B. And again, once I write the problem, if you want to pause the video and just go ahead and solve it and then see if you did it correctly, that's totally fine. You can use it however works best for you. So let's try 7 divided into 37,152. Okay. Now again, my first step for me that I always do is I kind of give myself the helpful numbers by listing my multiples. And you can still draw the dots. 1, 2, 3, 4, 5, 6, 7. Some people the dots are helpful, some people you know your multiples. 3, 4, 5. So counting by 7, 7. 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 28. And 7 times 5 is 35. And again, if I didn't know my multiples, I could go here and I could count the dots. You always want to try and find a strategy that's going to work rather than just resorting to a multiplication chart. So this is a good one because you're kind of creating your multiplication chart. Okay, now we can go and try to start dividing. So my number I'm working with this time is 7. We already established that with our multiples here. So how many times can 7 people sit in 3 chairs? Hopefully you're saying, no, that can't happen. So remember, when we say no, we put our 0 because that's our O for our no. Okay, so now 0 times 7 is 0. I subtract and I get 3. Bring down the 7. Now 7 goes into 37. So I'm going to look over here and I got to 35. That's probably as close as I'm going to get. But just for good measure, I'm going to go to the next one. And yep, 35 is as close as I can get to 37. So 7 goes into 37 5 times. And 5 times 7 is 35. We subtract. 7 minus 5 is 2. 3 minus 3 is 0. Bring down the 1. Now we have 7 going into 21. Look over here, closest to 21. Oh, I have exactly 21. So 7 goes into 21 3 times. And 3 times 7 is 21. We subtract, and of course 21 minus 21 is 0. Bring down the 5. Now this is where you want to pay attention because this is where people tend to make a mistake. If I have 7 people in 5 chairs, can 7 people sit in 5 chairs? Look at your multiples. Is there a 5 anywhere on here? No, the closest we have is 7, but that's over 5. So it cannot happen. So again, we're going to put that 0 for that no, it cannot happen. 0 times 7 is 0. We get 5. We bring down that last digit of 52. Now, we got to do a little bit more. So let's see. 7 times 7 is 49. We're getting closer, but not quite there. Let's see. 7 times 8 is 56. Oh, we went over. We couldn't go past 52. So I do not need to keep listing anymore. I know that the closest I'm going to get is to 49, and that is 7 times 7. And if I subtract, I get a remainder of 3. So 5,307, remainder 3. Oh, I kind of messed that up there. I'm making it worse. Oh well. 5,307, remainder 3. Okay. Let's try a few more. Hopefully you're starting to kind of get the hang of it. And again, if you know a different way to do it and you're getting the same answer, that's fine. There's no right way or wrong way or better way. Well, there are wrong ways, but there's no better way necessarily. Okay. Let's do C. Let's do 9,354 divided by 9. Everyone's always scared of 9s. So, again, my first step is to list my multiples. 9, 3, 4, 5, 6, 7, 8, 9. Okay. 1, 2, 3, 4, 5. 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36. 9 times 5 is 45. And a fun little 9s trick for you, if you look at it, the 1's place, 9, 8, 7, 6, 5, it'll go 4, 3, 2, 1, 0. 10's place goes up, 1, 2, 3, 4, 5, 6, 7, 8, and so forth. So it's pretty cool. So if you list your multiples, the 9s are pretty simple, or they can be. All right, we've got some multiples listed. Let's see how far we can get. If we need to do more, we'll do more. All right, how many times can 9 people sit in 9 chairs? So I'm looking over here on my table, my multiples. Closest to 9 without going over, we have exactly 9. So 9 people can sit in 9 chairs 1 time. And 1 times 9 is 9. We subtract and we get 0. Bring down my 3. Now I'm going to ask myself, can 9 people sit in 3 chairs? Can 9 go into 3? You should be saying no, because if I have 9 people waiting to go sit at a table for dinner, and they only have tables of 3, or they only have a table of 3 chairs, they're not going to be able to sit there comfortably. So we're going to say no. We're going to put a 0, right? And 0 times 9 is 0. Subtract and get 3. Bring down the 5. 9 goes into 35. Well, look at right. Closest we can get is not 36. That went past it by 1. So we're going to go with 27, which is 3 times. 13, 12, 11, 10, 9, 8. Bring down the 4. 84. Oh, we got some ways to go. But we can use that cool new trick. Or we can count dots, or we can do whatever you feel comfortable with. So 6, 7, 8. Let's see if we do go further than that. So 45, 54, 63, 72, again, 5, 6, 7, 5, 4, 3, 2. We're trying to get to 84 though, so let's go 9, 81, 10, 90. Oh, that's too far. So we'll stick with 81, which is 9 times. And we subtract and we get a remainder of 3. So 1,039, remainder 3. Okay. Let's try next one. D. 67,943 divided by 4. Again, I'm going to list my multiples. We'll go with 5 and see if we need to go further. So 4, 8, 12, 16, 20. And again, if I didn't know my multiples, I can count the dots. That's why the little table here is helpful, because we can just count the dots. All right, let's see what we can do. 4 people, 6 chairs. 4 goes into 6. 4, 8's too big, so we're going to go with 1 time. 1 times 4 is 4. Subtract and I get 2. Bring down my 7. We're at 20. Let's keep listing. So 6 is 24. Close. 7 is 28. Oh, too far. So it's going to work 6 times. 6 times 4 is 24. 7 minus 4 is 3. Bring down the 9. Gotta keep going. So this just shows you got it. You just keep going. 28, 29, 30, 31, 32, 9, 32, 3, 34, 35, 36. Sorry, I'm trying to catch up with myself. I lost focus. Yeah. Okay. Sorry. Brain fart. All right. So 40 is too big. 36 is going to win, which is 9 times. We subtract 36, or 9 minus 6 is 3. Bring down the 4. 34. The good news is I have nothing left to list my multiples on. I got down to 10, which you'll never need that one. 34. Back on track. Come on, Laka. 32 is as close as we're going to get. That's 8 times. 2. Bring down my last number of 3. Okay, 23. 24 is too big, so we're going to go with 5 times, which is 20. So another remainder 3. Have they all been remainder 3s? Look at that. All but the first one. Funny. So we have an answer of 16,985 remainder 3. Okay. So hopefully you're feeling better with that. We got 4 problems under our belt there to practice. Again, my suggestion is always to list your multiples. It helps you so you don't have to keep thinking about the multiplication facts as you're doing long division. Long division's hard enough. We don't need to add all the extra thought processes in the middle. So I like doing the list of the multiples, and you can kind of just circle it, use the different colors if that's helpful. Do what works best for you. And then the other suggestion I would make is make sure you're writing nice and neatly, keeping everything lined up. If you need to, print off some graph paper and just help yourself write really, really neatly. All right, hopefully that helped. If you need more problems, more practice, let us know in the comments and we'll do what we can. Good luck.